Hi there. Let's discover how something called ArcGIS Online can be used to enhance a study and bring a story to life. In this particular case, let's examine the 10 most expensive streets in the USA and find out how their spatial perspective through something like a web GIS, ArcGIS Online specifically, can add value to our investigation. Let's get started.
Let's dig into this lesson, which I've entitled Big Bucks, examining the 10 most expensive streets in the USA. As I mentioned, this activity uses ArcGIS Online, a web-based Geographic Information System, or GIS, as a tool for examining these 10 most expensive streets in the USA, as measured by the price of office rental space as reported by MarketWatch in the Wall Street Journal. This activity is aimed at university level, but it could also be used at the upper secondary level. It can be used as an independent assigned activity to students or in a whole class discussion format. There are 30 questions, and I estimate that it will take about 2 to 3 hours to complete all the questions. It could also be done, of course, in an abbreviated format in one class period. No previous experience with GIS is necessary, but this activity does rely heavily on spatial thinking and the geographic perspective. Computer requirements are web browser and internet connection. That's it. It can be run in a lab setting or with one computer and a projector. The lesson is only 3 pages long, and as I mentioned, you can go through all of these questions or select just some of them to use in your class. Alright, let's get started. What factors influence how expensive it is to rent or buy a house in a community? What areas of your own community are more expensive to rent or buy a house? Why? What factors influence how expensive it is to rent an office in a community? Discuss the differences and similarities between the cost of home rental or ownership versus office rental cost. Where do you think the most expensive streets for office rentals are in the USA? How about in the world? Why? Create a list of 10 streets for the USA where you hypothesize that renting office space is the most expensive. Now let's examine the 10 most expensive streets spatially using ArcGIS Online. What we're going to do is go to arcgis.com. www.arcgis.com. That's ArcGIS Online. In the search frame, let's search for 10 most expensive streets, owner J.J. Kursky. We've got one result. Let's go ahead and open it in presentation mode. Let's go ahead and start that presentation and look at our first slide. Why do you think the 10 streets are distributed across the country as they are? It looks like they're coastal, doesn't it? There's a bunch of them out here in California, there's some in New England in the mid-Atlantic states, and there's one down here in Florida. Interesting. Here's the first street, which is available on the next slide. Sand Hill Road in Menlo Park, California. Here's the second street, Fifth Avenue, New York, New York. Perhaps this was one that you hypothesized would be in the list of the top 10. Here's the third one, Greenwich Avenue in Greenwich, Connecticut. Why would that be? Now we've looked at 3 different streets. We've looked at one in California, one in New York City, and one in Connecticut. Look through the remaining 10 slides, one slide for each of the 10 most expensive streets. Describe 3 similarities and 3 differences that you notice in the 10 photographs. Which of the streets, based on the photographs, is the most appealing to you if you were looking for office space, and why? Change the base map from streets to an image for the first 3 streets: Menlo Park, New York City, and Greenwich, Connecticut. Try unlocking the first slide and other slides so that you can pan around the neighborhood. Let me illustrate. Let's go back to the first slide, Sand Hill Road, Menlo Park. I'm going to unlock that, and then I'm going to change the base map to an image base map. I'm also going to get rid of that ground photograph. Okay, I'm looking at the land use and land cover there. Looks like some pretty big office buildings. Interesting. So I can get a sense for what that neighborhood is like. Let's go to New York City. Doing the same thing now, unlocking the slide, getting rid of the ground photograph. I can see that Central Park is right here, Fifth Avenue is running this way. Change that base map, just like we did before, to an image base map. Looks radically different from California, doesn't it? Let's take a look at Greenwich, Connecticut. Unlock, change the base map to image. Interesting. Once again, quite different from what we saw in California and New York City. Now, describe these 3 neighborhoods based on what you observed on the satellite imagery. Next, in your map, toggle each of the following layers on and off: USA population density, USA median age, and USA median net worth. For example, there's a layers button here. How do we do that? Over here on the left side is a layers button. Let's go ahead and turn on population density. Now I'm going to zoom out and click on different block, unlock so I can zoom out. So here's my population density. It's like 576 people per square mile, 3,000. Go back to unlocking, looking at the layers, population density. Zoom out a bit. 34,000 people per square mile here. 35,000 people per square mile here. 94,000 people per square mile. What about Greenwich? Zoom out a bit. 6,000 people per square mile. So we've got several different densities, don't we? We have a medium density right here in Connecticut. We had a lower population density in Menlo Park, high population density in New York City, as you would expect. What about some of these other layers that we chatted about? Let's go back to the Layers tab. Let's look at median age. "45 years there." Let's go back to New York. "52 here in these neighborhoods in New York. 51. Take a look at median age. 52 there. 45 there. Let's get some more real estate back. But radically different here. Why? Well, this is the campus of Stanford University. So you've got 20 median age there, but just outside that you've got 42, and just outside there you've got 52. Let's take a look at another variable. How about median net worth? The median net worth in one of these neighborhoods adjacent to the expensive street was $668,000 in 2010, 684% of the national average. Median home value was 437% of the national average there. Wow. And here's a median net worth in this neighborhood of over $1 million, 1,023% of the national average. Net worth here. That's once again $1 million here in New York City. In this neighborhood, 683,000. What about Greenwich, Connecticut? This neighborhood, though, interestingly, is 79,000. It's actually below the national average. So why is this street so expensive? Clearly there's a lot going on here, and we're only looking at 3 different variables. But it begins to help us understand what's going on in these 10. Okay, in this lesson, I'd like you to fill out this table. Define what each variable means. You might need to do some outside research to find out what median net worth actually is. Examine the legend, as we've done, for each layer to obtain the values for each neighborhood. Under each city, describe the pattern of each variable in the expensive neighborhood surrounding the pushpin. Zoom in or out so you can fully understand local patterns compared to the surrounding neighborhoods. The only thing I neglected to show was how do we get that legend. Let's take a look at the legend here. Okay, so any one of those layers, you can click on this legend selection and get the legend. You can go back to layers and you can click on, for example, median age, and there's your legend. Okay, so that's how you get the legend. But more importantly, fill out this table and compare the population density, median age, and median net worth for these different neighborhoods. Alright, so which of the 10 streets would you say, based on your observations, has the highest population density? How about the lowest? Which of the 10 streets would you say, based on your observations, has the highest median age? Or the lowest? Which of the 10 streets would you say, based on your observations, has the highest median net worth? And the lowest? Continuing on, what influence, if any, does population density have on office rental cost? Why? What influence, if any, does median age have on office rental cost? Why? Finally, what influence, if any, does median net worth have on office rental costs? Why? Are there any spatial relationships between these expensive streets and these 3 different variables? Next, read the following article in the Wall Street Journal, The 10 Most Expensive Streets. Let's take a look at that. Here is the article from the Wall Street Journal, The 10 Most Expensive Streets in the U.S. In each one of these, as you can see right here, there is a text. There's text that accompanies each one of these photographs. So you can page through here and look at all 10. The 4th one, the 5th one, Pennsylvania Avenue in Washington, D.C. The 6th one, Century Plaza Towers, Avenue of the Stars, Century City, California. Here's a place in West Palm Beach that we looked at earlier on that national map. In Massachusetts, Boylston Street. And here we've got Fashion Island in Newport Beach, a bit more about the data set. So, inside the lesson, I ask you to do the following. Name 2 additional things you learned from reading the article that you did not know based on examining the maps. Do you think that the price per square foot is an adequate measure to determine if a street is expensive? What other measures do you think would be useful? Now, part of spatial analysis is temporal. So let's think about this. Where do you think the 10 most expensive streets were in 1900? Surely they didn't have the same exact pattern as they do today. Where do you think they were in 1900? New York City? Boston? Washington, D.C.? Why? Where do you think the 10 most expensive streets will be in 2050? Why? Write your own question about the 10 most expensive streets, and then answer your question, or at least grapple with that question. Next is one of my favorite parts of the whole lesson. Zoom into your own community. What patterns of population density, median age, and median net worth exist in your community? How do I do that? I'm going to go to the Mapping tab, and I'm going to find places. My community happens to be Denver, Colorado. So right now, I'm looking at most of Metro Denver. I'm looking at median age right now. I can change my layers at any time, right? Here's median net worth and population density. So it's interesting to look at patterns. If I look at the median net worth, for example, I can see that central Denver is relatively low, but there are some pockets of anomalous block groups and census tracts. Down to the south of Denver here, I've got a much higher median net worth. Interesting. What about median age? Wow, central Denver and south central Denver is quite young compared to the rest of Denver. Okay, we've talked about doing this for your own community and looking at patterns that might exist in your own community. Sometimes, though, the lack of pattern is just as interesting geographically as a pattern. How do the patterns change as you change the scale by zooming in and zooming out? Why? Let's take a look at that for Denver. So I'm looking at net worth. I'm going to zoom in, and I can see that not all neighborhoods are created equal. I've got some fairly high net worth neighborhoods juxtaposed adjacent to lower net worth neighborhoods. But even in the higher net worth neighborhoods, I can see that not all those are created equal either. How do you think these patterns will change over the next 20 years? And why? What other variables do you think would be helpful to understand the price of office space? Here in our lesson, we've looked at median age, median net worth, and population density. We've also looked at the imagery to look at the local land use. But what other variables do you think would be helpful to understand the price of office space? Now, using the Add Data button in ArcGIS Online, find out if those additional variables exist that you've identified in the previous question. Add them to your map and describe the patterns that you uncover. Let's take a look at that. That's over here under Add Content. So here's where I found the median age and the median net worth. You could enter other terms here in the Add Content window and start exploring those variables. In other words, these maps are fully customizable. Think of them as your toolbox for investigating this particular issue that we're uncovering right now. If time allows, investigate the price of office space in specific areas of your community and compare those prices to a satellite image, population density, median age, and median net worth. Create a 5-minute presentation containing 5 slides that tells your story and save it in ArcGIS Online. Give that presentation to your class. Remember that when we were out here, we had a presenter, right? And it's got these slides here along the bottom. Each one of them was telling the story of one of those streets. So here's Avenue of the Stars in Century City, California, Royal Palm Way in Palm Beach, Florida, etc. You could create a set of slides for your own community. That's what I'd like you to do. It makes it a lot more interesting when you add the personal touch, the local knowledge that you might have. Finally, how have these WebGIS maps, specifically ArcGIS Online, and the spatial perspective helped you to understand the cost of office space?
All right, well, we've illustrated how the spatial perspective through a WebGIS, specifically ArcGIS Online, can be used to enhance a study and bring a story to life, specifically here with the 10 most expensive streets in the USA.